Hello, everyone, and welcome to We Meet at Digital Days. My name is Lisa Richter, and I will moderate this presentation. We are very pleased that you took the time to participate in our virtual conference. The topic of this presentation is Horticulture LEDs, high and low power application examples. Our speaker is Gelio. He will hold the presentation and will answer your questions. Before we start, I would like to point out one thing. You will be muted during the presentation. This means that you cannot ask questions via microphone during the presentation. Nevertheless, you have the opportunity to ask questions during the presentation at any time via the chat function. You will find the chat function in the control panel. This presentation will be about 30 minutes long. The chat questions will be answered in a Q&A session following the webinar. There are 5 to 10 minutes in addition scheduled for this. If we are unable to answer all of your questions within this time, we will answer them via email afterwards. If you still have any other questions left, just mail us at exhibition@we-online.com. We will try to answer all of your questions promptly. At the end of the webinar, you'll be asked to participate in a feedback survey. We would be pleased if you take the time to fill out a survey and help us to improve our event. You will receive the link to the presentation in the next few days, and the recording will be available at the website shortly. So now I will hand over to our speaker, Celio, and I wish you an exciting presentation.
Hello, everybody, and herzlich willkommen or welcome to my presentation about horticulture products. Thanks, Lisa, for the nice introduction. And now I would like to start with the presentation. And first of all, a short agenda, what we are going to talk about here. I would like first to introduce a little bit horticulture lighting, the main parameters and what plants are interested for. Then we will go over some information from our application lab, what type of applications are there, what have we seen in our own Würth Elektronik garden, and how this benefits us. At the end, I would also like to show you some examples and differences between the high and low power LEDs, or what are the difference and benefits there, and how you can choose the correct one based on your illumination or your lamp, and end up with some further helpful tools and an overview what else we can help you, and then a summary. But first, a short motivation, a few words about why horticulture. I think for everybody in the modern world is now clear that we are looking for more and better food sources, because our food resources on the planet are scarce. And the most important here, what we consider, is the sustainable sources, or sources where we can produce food using less energy, or energy that we can recuperate later, and thus make it the whole process more efficient. Of course, the second part is to have a more healthy and nutrition-rich diet, so we can produce better food with better qualities, and also produce the food whenever we want and how we want, because and then be efficient and not throw away a lot of food. And of course, environmental friendly and independent sources that can provide food fresh on the table. And this is why horticulture is one of the main topics, or how we can produce this. And here are some points about it. And first of all, some numbers from internet. Currently, for Europe, we produce around 20% of our vegetables or green products on the table in greenhouses. Of course, this is not from yesterday. We have more than 20 years of development or production. And the current main technology at the moment is the HSP lamp, high pressure, high sodium pressure lamps, which take over 90% of the market. Please take these numbers as not granted, because this is some internet sources, and numbers value a lot each year. It's a very dynamic market that grows a lot, and LEDs take more and more place in this market or in this aspect. And why LEDs take more place? Because the current technology of the HSP lamps, they have low efficacy, they have broad spectrum, but they were up to now the cheaper and efficient, not efficient, but the simple and simple solution to the problem. When you have a lamp, you just turn it on, it provides light to the plants, and the plant grows. But of course, as we are talking about more efficient or more sustainable solutions for the future, we see that with LEDs, which have a narrow spectrum and are more than 10 times more efficient than the lamps, with efficiency up to 50%, we have a saving potential on energy consumption in such greenhouse between 30 to 50% or even more, depending on the lamp. And of course, what we can see later with some results, we can have better yields, better plants, shorter cultivation time, shorter working process, and so on and so on. So this is the improvement that we can show or in a short term. But how we can do it, what the plant needs, or why the plants can do this with the LEDs. To understand this, first we need to understand how the plant works. And on the graph here, you can see in dashed lines the main molecules or the main wavelengths at which molecules are absorbing the light, the sunlight or any light source that comes to the plant. And these molecules work or are responsible for the photosynthesis in the plant, or how the plant grows, or the process that the plant grows up. As you can see, in the region between 400 to 700, we have a few dominant wavelengths, like the 450 nanometer up to 500 nanometer, and then from 650 up to 750 nanometer, we have another molecules that absorb the light. So this is basically the PIR, or photosynthetic active radiation region. On the market, you can find it between 400 to 700 nanometer. In new products, usually goes up to 800 nanometer, the extended region for the far red product. And basically, what we can see here is that if we provide the plant with some specific wavelengths, we can boost different processes. And here I would like also to note that we're not trying to explain here if the light is better to be grown with full spectrum or monospectrums. We just want to point that different wavelengths, if we boost them, we can get some effects. And these effects we can see even by full spectrum, even by monospectrum lamps. The second part, or the second efficiency part, if then we go to the lamps, this is the photon efficacy, or I think a lot of people on the market know this as the lumen per watt value by white LEDs. For the plants don't see in lumens or don't detect the light in lumens. What's important for the lamp is the photons, or how many photons or light carriers fall on the plant. In this case, we talk about micromoles per joule, and this is the value that basically describes the efficiency of horticulture luminaires. It's similar the lumen per watt. But how we can better describe the photon efficacy? Usually the lamp or the horticulture application will also have two different additional values. The one is the ppf. This is the photosynthetic photon flux. This is the amounts emitted from the light source in form of photons. You can see this on the left side of our graphic. All the points are like photons, are the photons or schematic photons. The time, how many photons per second is the ppf value or micromoles per second. Micromole is chemical value for number of carriers, and per second is the typical output. This is the typical information that we can get from the LEDs to see if they're good for our plant or how much plant energy they can bring. And of course, not only the LED, it's important also that the plant absorbs this, or the plant has an area. It's like if you work at home, what's the illumination on your desk? This is the ppfd factor, or the amount of photons that hit 1 square meter per second. Or on the right graph, you can see the 4 LED, they spread the photons in each direction, or the viewing angle, and we can compute the ppfd as the amount of them that go over area. And this is important when we compute the lower or the area where the LEDs, the plants are, to know how much the plants are taking from the energy. But where and how we can set up this? This is the typical application that you will find a schematic greenhouse in our view. Of course, you see the main benefits here. One of them is the lower or the easy maintenance with lifetime of the LEDs or the emitters more than 36,000 hours in real greenhouse conditions compared to the standard HSP lamps, which usually have 10, 15, 20,000 hours lifetime and then need to be changed. And of course, the other benefit, the energy efficient, with efficiency of more than 50%, the LEDs are way more efficient compared to the lamp, which not only have efficiency of below 10%, but also the spectrum is a very broad spectrum ranging from near UV or the UVA up to far infrared. And this means that a lot of the energy or the spectrum is not going to be used in reality for the plants. So these are the main benefits. And of course, as we can see in the next few slides, we can improve the plants flowering, we can improve the biomass of the plants, and so on and so on. But one of the main points that here we need to see is that the different applications that we can provide. Of course, you can see the supplement lighting usually is a lamp that needs to be small in size and is put in an open greenhouse with glass housing or with a glass roof, where you supplement or you help the sunlight by the growing. So you add up additional boost for the plants. This is also the traditional growing farms at the moment, where you can also put a lot of HSP lamps. But with the LEDs development, we now see more and more farms are going to the stacked farming model, where you have the different stacks in a rack, and then you can grow more layers of LEDs. Of course, more efficiently using the space into your farm and And then, of course, you can also do it without any environment control from the outside, or any to consider the environment that is outside of the farm. So example, such farms you can find from the desert at the equator up to the North Pole and the polar caps, and even in space. And then the third model that is rather new is the intercanopy, where you can even go with the LEDs into the plant or around the plants and supply this energy, the light at the leaves, exactly where you can take it or absorb it. But these are the different applications. Now I would like to show you some of our experiments, how or what we did, because we are also interested not only producing the component, but also help you in your next steps to build up and to make the perfect garden and the perfect greenhouse. We have also in our house a small experimental lab which we built up with 14 chambers with fully flexible spectrum and power outputs up to 150 micromoles. As you can see, the nice spectrum that we can achieve from blue, red to mixing of blue and red and supplemental full spectrum with different colors, which you can see in the bottom. And what we did in one of our first experiments, which I want to show you here, is we tried to grow a basil to find the right recipe or the right model, if we can find some difference between the different growing recipes. What we have learned that the first step is that different light intensity helps grow faster or lower. As you can see here, after 35 days, the difference or the distance or the difference or the height between the plants is very visible, between 50 micromole per meter per second quadrat, a ppfd factor of 50 up to ppfd factor of 150. We see that the plant is almost 3 times higher, bigger, and it has more leaves, it has more mass, and altogether the plant is a lot better. What else we wanted to study here is a bit about what the plants or how the plant will look like if we use different wavelengths. As you can see, this is also a place where you can play with the plant and provide different results or get some different results. As you can see, full spectrum with some supplemental light on the left side, only white LEDs on the middle, or the red blue solution on the right side. All of them work for the plant, but there are small differences which needs to be proven in further steps. So here we have just one experiment where we have seen that the average height when we use the monospectrum is so to say the red blue solution, and full color is the white solution. We see that with a monospectrum we get higher plants. We say we can get selling height a lot faster, 6 days faster, which means in a whole year we can have 3 times more crops than the full cover. Please take these numbers with some consideration, because this is only one experiment made in our lab, and further information or further working on this needs to be done. But of course, we're always working further, and if you have any question, you can always contact us and have more information, or we can go into a discussion. But what else we can do, not only looking at the plants and which spectrum they have. As we see, spectrum has a difference, but nobody's willing to play with it and see that it's working. What people need is a solution that will be turned on and work automatically. It's a solution that will give you the correct and the perfect answer. I think here we are still in development phase, but even making the further solution, we need to deliver it to the plant. And this is the second part where I wanted to talk and to give you some more information and differences between the high and the low power products. What else we are doing in our company? We do also some illumination simulations to compute the characteristic to see if the lamp is the correct or if the lamp will provide the illumination or the PPFD at the correct place. As you can see here, we started with a simple simulation. We started PPF of 10 micromole per second, and we do this with two different solutions. One is on the left side with 12 mid-power LEDs, or on the right side with 4 high-power LEDs. As we see, if we apply this solution to a stacked housing where we have normally a illumination surface of 2 by 2 meter in this case, it's always dependable, and a very low lamp height, so the lamp is very close to the plants, then we can see the difference between using a mid-power or high-power LEDs. The mid-power LEDs provide a lot more homogeneous solution where we have a higher illuminated area, while the high-power LEDs just provide 4 peaks around the LEDs, and this is with the standard 120 degrees viewing angle of the product. And as you see here in the middle, we have a lot of area which is not illuminated. Of course, this is just to show you how it all works, and in reality the things look a little bit different. We also made the experiment making a real case scenario with a lamp that provides 100 micromole per second, using the same room size and the same distance, 2 by 2 meter and 30 centimeter distance between the working surface and the lamp. As you can see, we have a very nice distribution of the low power LEDs. For the high power LEDs, we worked up a few solutions that might be feasible, and we see that we can still find some interesting solutions, but still the high power LEDs show different peaks, and this can also be seen on the 3D simulation of the surface or the 3D plot of the surface. The low power lamp have the peak too, but as you can see, there is a homogeneous plateau on the top, where for the different solutions with the high power, you can see this peak that provides a line in the middle which is not that homogeneous. Of course, these simulations are done for a vertical farming, and depending if one needs a vertical farming, what's his geometry, what type of light he needs, or if he wants to make a supplemental lighting, then the combination here is different. So one needs to also to take into account how the lamp is constructed, what type of lamp is constructed. If you need further information about this, you can always contact us, and I hope that soon we will be able to provide also this type of simulation in our Red Expert tool. I hope you're all familiar with our Red Expert tool that can give you a lot of different computation and simulation parameters. So just look for it and next year I think we will have some nice news for you. Just to summarize everything, I just want to present you now what is the solution that we offer. And of course, the high power Horticulture LED in the size of 3535 with ceramic substrate and power density of up to 600 milliwatt or electrical power up to 2 watts. Then they are available in all the horticulture colors, in the red, yellow, green, and blue colors, of course, the white, infrared, and ultraviolet. In addition, we also offer the mid-power products with driving current of 150 milliampere, sorry. And again, the three horticulture colors, the 450, 660, and 730 nanometer, and of course solutions which allow you to add your own colors, the standard red, yellow, green, blue, and of course the wide spectrum from 2700 up to 6000 CCD for your flexible solution. And of course the benefit here, or what you can use at the moment, the Red Expert Horticulture Calculator can give you the ppf, ppft value and the energy efficiency of your luminaire at the current status. Just follow the link and register. Then pretty intuitive, you can compute the input and the output of the lamp and see the spectrum of your desired lamp simulation and the LEDs that you want to put. Of course, we also provide you with a lot of application notes in our webpage, Let It Grow, where you can find information about our test experiments and give you different tips how to construct your light or what your plant will need, and etc. And of course, we have even more for you, and this is the lighting development kit which we introduced this year. The lighting development kit gives you the possibility to test your recipes and create different reference designs or use it as a reference designs for your lamp. It offers you a full spectrum or mixed spectrum horticulture PCB that can be controlled over our app available for iOS and Android, the VE Illumination app, free to download, of course. And basically with it, you can try to grow your own small plants at home or use it and just multiply and expand it for your greenhouse. The lighting development kit had even more tips and more availabilities for them. Just ask your sales representative and he can help you to order and get your own lighting development kit. With this, I would like to end up my presentation and just a short summary of my talk. As we see, horticulture is a growing market and demand on efficient LEDs from the industry will increase with each year. And the reason for this is that horticulture will provide a sufficient energy efficient way to provide more food and more healthy and nutrition food, even in regions where it is hard to grow and lack such food. So this is one of the main benefits that we are looking to improve and to provide more green and healthy food for the population of the world. Of course, what we see at the moment is we need further research and support to find the correct recipe, to find the best and the best working solution. in this aspect, Würth Elektronik is working also with a lot of academic institutions and a lot of different groups, and working into the research to make the horticulture even more efficient. And excuse me, what we have seen, LED lamps need also important consideration: what type of spectrum we need, what type of illumination we need, how we can do this. And in this case, we are here to help you and to give you the first help and important tips about how to make your application better. Oops, excuse me. And of course, we are here to support you and help you in your application with our tools, with our expertise, and with our know-how.
Thank you very much, Telio, for your good presentation. It was really interesting.
Okay, I also wanted to say thanks a lot for the presentation and for the attention. And excuse me, but the air in this room, in our room, is a bit dry. I think they use some active filtering here to make it even better. And I'm welcome now. I want to welcome you for some question and answer sessions. And thanks a lot, Lisa.
Thank you. So let's have a look at the questions. There's one first question. Are there any information about the necessary wavelength for underwater plants?
That's a very nice question. It's a very interesting question. For underwater plants, what we have seen from our study is, oh, sorry, I hope you can hear me. What we have seen from underwater plants, most underwater plants use blue light. Sorry, I needed to use the blue light because in the blue spectrum, the light travels more further into the water. So for any underwater plants, we recommend using only the deep blue or 450 nanometer, which is very good for different aquarium applications and different so to say, yeah, aquarium lighting, ambient lighting, and to grow some seaweed in the aquarium.
Okay, great. There was also a question from an attendee who is still working at a greenhouse illumination project, and he asked, we realized that physical heat on the leaves of our plants is quite important for the overall heatness of the plants. The LED illumination does not support that. What to recommend to that findings?
That's a very nice question, of course, and very interesting. And of course, this is one of the differences. But if we look on one side, that LEDs doesn't have this convection of temperature, LEDs still provide a lot of light, and the convection is not there, so you don't have this heating of the plant. To one point, it's a benefit because most of the current lamps provide too much heat. The HSP lamps provide too much heat if you go close to the plant. If you're far away, of course, this is not a problem. But what we have seen also is that a lot of this heat on the leaves will also be generated from the plant itself with the photosynthesis. And we haven't have any experimental data what's the plant temperature in comparison between HSP lamp or LED lamp. We have seen that different LED solutions can bring the leaf temperature even to a higher level. I think one of the experiments that was done from one of our partners where we provide and participate with the lamp was supplemental lighting from LED and HSP lamp. And basically they were far away from the plant. And in this case, the plant, the tomatoes with the LED lighting had a few degrees higher leaf temperature. But this is also something that not my expertise or not biology expertise. I would just recommend you please contact us and we can work this out together. We have also biology specialists in our company that can probably give even better answer than mine. But I don't see that this is any drawback on the LEDs usage.
Okay, thank you. So now we have finished with this presentation. If there are any questions left, we will answer them via email afterwards. Thank you very much for your attention, and I hope you enjoyed our presentation. The next presentation topic is shielding options and solutions, what best fits with your design. See you there and enjoy our digital days, and goodbye.
Thank you. Bye-bye.